Hello everyone, welcome to the next lecture on the calculus. Today we will discuss about the chain rule which are help for the multivariate function. Myself Dr. Garg, working in the School of Mathematics Thapar Institute. You can simply contact through either email IDs or simply follow this link for finding the various videos. What is the chain rule are there? So all of you know that how you can find the derivative of the function, say f dash or df by dx when x is dependent on more than one variables or f is there. For example, if you are considered about the two variables, if w is a function of the x and y and again x is dependent on the function of the t, then how you can find the partial derivative of this with respect to t? So that is called as the chain rule. So then you can easily say that w is also differentiable function of the t. Here this x is dependent only on the one parameter, that is called as the small of t. That's why now we can define like dw by dt. Since remember x is dependent only on the one parameter, that's why we write as a dw. But if x is depending on the more parameter like say t1 and t2, then instead of this we can write this as partial derivative with respect to t1 and so on. So now this is the chain rule about that. W is the dependent on the x, so this is w dependent on the x and y are. Similarly, if there are the three functions, then we can write like of here. But the question arises, how you remember these long formulas are there? There's a very shortcut tricks behind that. You always think about that. Since your target is to find this, you have to write the whatever the written here w can write here and t in this case. Now w is dependent on the values of the x and y. You can see w is dependent on x. So this part it can be written as partial derivative because it is more than one, so it can be written here. Similarly, this value can be written like of this way. Now x is dependent on here, so this can be written as this, or you can simply, since x is dependent on the one parameter, so you can write like of here. So this value. So now how you remember, how you find this value of dw by dt? That's a very simple. You can write this multiply by this, that is you can see here, and this multiply by this is my second part. So this is the way you can simply remember this chain rule. Similarly, for the three-dimension problem, if w is dependent upon the x, y and z, so this part is nothing but partial derivative with respect to x, this is partial derivative with respect to y, this is partial derivative with respect to z, and then you can see this is the tree diagram about it. Now how you can write this value are there? You can see the first pair partial derivative w with respect to x, and here this is the first portion. Similarly for the second one you can write like this way, and similarly for the third one. If you look about that again, if say w is the function of the x, y and z, and x, y, z are again depending upon this here, so then what you can do is you can see x is dependent upon the u and v, so that's why there is a partial derivatives. So again the rule are similar. You can start with the w and u for the first part. W is dependent on the x, y and z, and x is y of here. So you can see x is not dependent upon here, so you can write like of this side. So how you find this value? That is a partial derivative this is the first way, this is the second, and this is the third r here. Similarly, you can find this w over the v. W is again depending on the x, y and z, and like here you can remember this one. So how you can solve this chain rules in this numerical examples? Now you can see your target is to find the partial derivative w with respect to u. So you can write w and u here. W is the dependent on the x, y and z. So this is the function of x, y and z, and u is dependent on the x, u is dependent on the y, and u is on the z. So this is the chain diagram. So this is the value of the partial derivative with respect to x, this is the partial derivative with respect to y, and this is my z. This is x with respect to u, this is y with respect to u, and this is z with respect to u. Now you can find the value of this. What is the partial derivative of w? What is that? This is partial derivative of w with respect to x. What is that? This is nothing but my y plus z. What is the partial derivative of w with respect to y? So this is x plus z. What is the partial derivative of w with respect to the z? So w with respect to z is nothing but my y plus x. Similarly, what is the partial derivative of x with respect to u? You can see it's a 1. Y with respect to u, again it's a 1. This is my v. So that is the here. Now how you can write that? This is nothing but my y plus z of 1. This is my first pair. Similarly for the second pair, this is my second pair, this is my third pair. Now since I need the answer in the w or the u form, so there is no need of the x, so you can simplify them here. So I have to substitute the value of the x, y and z in this expression so that all the answers can be written in the form of u or the vr. This is the required answer. Similarly, you can find for here, you can draw the chain diagram with respect to v. Again, what is the partial derivative of u with respect to the x? That is nothing but my y plus z. This is x plus z. This is my x plus y. Find the partial derivative of x with respect to v. So x with respect to v is my 1. Y with respect to v is minus 1. This is my u. So what is the answer of this? This is y plus z of plus 1 plus of z plus x of minus 1 and x plus y of u. So you can simplify them. You can see I can open this, z will be cancelled out. So it will be y minus x plus x plus y of u. So you can substitute the value of y here, x here, and then so on. You will get the required answers. Look at the second example. Now you can see I need the partial derivative of z with respect to the r. So this is z, this is r. Z is dependent on the x as well as y, and x is dependent on the r, y is also dependent on the r. So you have to write like here. So this value is nothing but the partial derivative of z with respect to the x. So what is the value of the z with respect to x? So you can see this is nothing but 4 e raised to power x ln y. What is that here is 4 e raised to power x over y. What is the x with respect to the r? So you can see x with respect to r is 1 upon r cos theta and of cos theta. Y with respect to the r is, that is nothing but my sine of theta. So you can see this will be cancelled out. So it will be 4 e raised to power x of this and here. So since I need all in terms of the r, so I can substitute the value of the e raised to power x from here. What is that? E raised to power x is nothing but r cos of theta. So I can substitute here, and similarly you can substitute, you will get this expression. Now for the second part, you have to write in terms of the theta. So this value remains same because there is a with respect to y. This is here. Now x with respect to theta. So how you can do that? This is 1 by r cos theta. This is minus r sin theta, and this is r cos theta. So r will be cancelled out. It will be nothing but minus of tan theta. So I can substitute 4ex into minus of tan theta and of it. So again you can see 4 e raised to power x is common, and this is the required. Or you can find the value of the e raised to power x from here, substitute, this is the right answer. Look at the another one is there. So again your target, now you can see this is the function of here. So what I can do is I can take this as a r, I can take this as a s, I can take this as a t. So you can simplify this as a function of it. Now I can start with the values of this first part. I can write u here, x here. So u is the function of r, u is the function of the s, u is the function of the t, r is dependent upon there. So what is the value of the u with respect to r? So it is nothing but my f dash. So, or you can say partial derivative of here. So this value is nothing but partial derivative with respect to s. This is my here. What is the partial derivative of r with respect to the x? You can see it is nothing but my 2x. This is my 0 because there is no r, and this is my minus 2x. So what is the answer of this? You can see I can use them. This is nothing but partial derivative with respect to r. This is with respect to s. This is with respect to t. So now you can see this part, this is a 0, and here. Similarly, I can draw for the partial derivative with respect to u, y. I can write like here. So this is again partial derivative with respect to r. This is with respect to s and with respect to t. So you can see r with respect to y is my minus of 2y. This is 2y and this is 0. I can substitute here. Partial derivative with respect to r is minus 2y plus partial derivative with respect to s of plus 2y plus 0. So I can take 2y as a common, you can write here. Similarly for this is nothing but partial derivative with respect to r, partial with respect to s, partial with respect to t. What is the r with respect to the z? You can see 0. This is my minus of 2z, this is plus of 2z. Now my target is to find this value, so we can start with the left hand side. I can start like here. So what is the value of this? I can substitute this pair, x will be cancelled out, it can be written here. Once you can open, it will be the required answer. Now you have to find this again, so you have to start with the w and with respect to the t. So w is dependent upon the x, y and z. So x, y and z, and x of the here. Now what is the w with respect to x? So you can see this is z is 0, this is my minus y cos xy. What is the w with respect to y? It is my minus x cos xy. W with respect to z is my 1. X with respect to t, you can see so 1. Y with respect to t is nothing but my 1 by t. This is e raised to power t minus 1. So once you will make this table, you can substitute this value here. So once you can write here, this is the expression. Now since we need the value at t is equal to 1, so if you substitute here, so what is the value of the x at t is 1? What is the value of the x? What is the value of the y and z? When t is 1, x is my 1. When t is 1, ln of 1, that is nothing but my 0. What is that? This is e raised to power 0 is my 1. So I can substitute x, y, z, all these values in this given pair. Or otherwise, you can substitute this value of the x and y here. You will get this at t 0. Secondly, you can also do like this way. You can substitute this value here. What is that? This is y 0. So this portion is my 0. Y is 0. Cos 0 is 1. So x value is my minus 1. T is my 1 upon 1. E raised to power 0 is 1. So minus 1 plus 1 is my 0 is the again right answer. Look at it again. So you have to find the partial derivative u with respect to x, first pair at this point. Again very simple, you have to firstly draw this. U is the function of the p, q and r. What is the partial derivative of u with respect to r? P. So q minus r is common, so it will be nothing but my 1 upon here. Similarly, partial derivative u with respect to p, so you can take as a u upon v square. Similarly, with respect to here is this. P with respect to x is 1, q and so on. So you can calculate this partial, you can substitute here. Again, you have your target is to find this. So you can see at x, y, z is my, after the calculation you will get here. At the point here, you can substitute this value. What is the value of p is my this, q is this, r is this. Substitute all this value here, you will get the required answer as 0. Similarly for this, a similar question is there. So again in this case you can see u with respect to the x. U is the function of the q, r and p. So it's the q, r and p and so on. So you can complete this values. U with respect to the p. So we all know that it's a sine inverse is 1 by p square. It is nothing but r e raised to power sine inverse p. And similarly here is with respect to r is q of sine inverse p. P with respect to x, we all know that it's a cos x. Q with respect to x is my 0. R with respect to x is again my 0. So the right answer is my only this portion, rest are my 0. So that is my here. Now at this point we need the value of p and q. So at this point, what is the value of the p, q and r after substituting here? So substitute this value here, you will get the required. What is the cos pi by 4? What is the e minus of this? So I can write this value as, what is that, log 1 0 minus ln 2. So what is that, minus minus plus half ln 2. So what is that, this is nothing but my, I can write this value as ln 2 raised to power half. So this value is nothing but my root of 2. Cos pi by is again 1 by root 2. This is again 1 by root 2. So it will be cancelled out. It is the right answer is root 2 is the right answer. Look at this one again. So now h is the function of this. So now you can find, start with the left hand side, h over the u. H is the function of x, y, z. X, y and z. So what is that? This is partial derivative with respect to x, partial derivative with respect to y, partial with respect to, what is the x with respect to u? So you can see x with respect to u1, y with respect to u, that is w plus v, w with respect to u is v w. So once you can substitute here, you will get this expression. Similarly, we can write for here this matrix H over the V, X, Y, Z. Once you will write this for U, this is for the W. So once you will pair this value, you will get here. Now what you have to multiply this pair by U, this pair by U, this by V and this by W and add them. So once you will start the left hand side, once you multiply with this U, you can see I can take partial derivative, this as a comma, this is U plus V plus W. From the second side, I can take this as a common. What is that? This is UW plus UV plus I have to multiply this by V plus UV plus I have to multiply this by W. So this is VW. And from the third side, I can take Z as a common. So this is UVW, UVW plus UVW. So you can see that what is this portion is, this is nothing but my x. So this is my x time. What is that? It is my twice of here. So that is a y. This is my y, this is my, and you can see this is nothing but my right hand side. Now the another concept is how you can define the implicit function like of this. So far we have defined the function which can be written as of this, that is called as explicit function. But how you can define this problem? So that's a very simple, we all know that how you can compute this one. Like for this you can do like of here, but you can see there's a very tedious calculations are there. Like for this example, again by using the chain rule we can get a simple formula of this. What is that? If you have any of the function f of x y is 0, like of this is my fxy, I can write this function like of here. So now this is my fxy. In this case, y is my dependent, x is my independent. That's why you can write here. You can see this is my dependent, x is my independent. Now you can define here. We can start with here. I can write this partial derivative with respect to x, this is partial with respect to y, and since it is function of 1 only. Now since f is a constant, what is a partial derivative of right hand side? It's a constant, it's a 0 is here. Can you find the value of the dy by dx from here? You can see it's a very simple. What is the fx is? Fx is nothing but the partial derivative of f with respect to x. Similarly for the 3 dimension, we can see how you can find the partial derivative of this. In this case, you know that z is the dependent, x and y are independent. So we can write again by using the chain rule. We can say f is a function of the x, y and z, and now we can see is the value of the x firstly. So you can see these values are my 0 and this is my 1 and this is my here. So we can see from here you can find the partial derivative of this. Similarly for dy. But the question arises how you can remember this. How you can remember that? You can see for this, whatever you have written here, it can be written in the numerator divided by here. So partial derivative of f with respect to y, partial derivative with respect to z, partial derivative with respect to the x, partial derivative with respect to y. Look at that. So if you look about this example, if I consider this value as a f, then how you can do that? That's a very simple. How you can find the dy upon dx? Either you can write is directly fx minus fx upon fy. What is the partial derivative of this f with respect to the x? 3x square plus y. Partial derivative with respect to y minus 4y plus x is the required answer. Else you can draw this chain diagram. You can write like of is the same answer. And if you want to find at the point 1, 1, you can substitute this, you will get the required answer. So this is the way you can solve this chain rule in a very simple manner. I hope you can simply enjoy it. If you want to find some another videos like the calculus, continuity, change the order of integration, volumes, area, all you can find the playlist Mathematics 1, channel name Dr. Harish Garg. Till then, you can simply like, share and comments on this video. Best of luck students. Happy learning.